right, so in case you didn't join us for our Google Meet, we're going to go through some exponential functions, look at their key features, and then figure out how we're going to compare these two. So you'll notice here I have my function 2 times 3 to the power of x. My ratio is this 3 value here. That ratio value is greater than 1. Another thing I'm going to look at is my coefficient. And if my coefficient is positive or negative, here my coefficient is 2, so that would be positive. So since my ratio is larger than 1 and my coefficient is positive, this is what my graph will look like. This graph is always increasing. It will never cross below my asymptote of y equals 0. So when I come back to this here, my function is increasing. My output values are going to relate to my range. These two things go hand in hand. So my range is all of my values that are above y equals 0. So that means my outputs are all positive. And then my y-intercept, remember if I make x 0, this thing right here will become 1. So my y-intercept is 0, 2. So there's our first one. Now our second one is going to have a coefficient that is now -2. So I'm going to come back over here, and I want you to watch what happens when I turn this other graph on. So red was our original function, 2 times 3 to the power of x. Blue is what happens when I make my coefficient negative. The only thing that changed was the coefficient. So my ratio is still greater than 1. Now my coefficient is negative. So my function is now, if I look at the blue one, it is now decreasing. So my range and my output are going to be the opposite of what they were before, because it has reflected or flipped over the y-axis. So now my outputs are all negative, and this means my graph lives in quadrants 3 and 4. Previously, I forgot to jot this down, when it's positive, that meant it lived in quadrants 1 and 2. And if you think about our coordinate plane, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. All right, getting back to our, oh, it froze. Who's surprised? So now getting back to this function here, I'm going to substitute in 0 for my x value to find my y-intercept. So this will now be 0, -2. Again, a reflection of what we had before. It got flipped. All right. Last but not least, in terms of our graphing and finding these important pieces. So I'm going to come back to Desmos, And I want you to watch what happens when I turn on my graph of 1/3 as my ratio. So it's like I flipped it over the y-axis this time. So instead of having a ratio of 3, I've created a ratio of 1/3. So now the range will be the same. The outputs will still be positive. I'm still in quadrants 1 and 2. We have the same y-intercept here of 0, 2, but my ratio is now smaller than 1 because it's 1/3. My coefficient is still positive, but because I have switched my ratio, it is now decreasing. So our outputs are still positive. So we're still in quadrants 1 and 2. Our range is still bigger than 0, and we still have a y-intercept of 0, 2. But because I have switched and my ratio is smaller than 1, my function now goes from high in quadrant 2 to low in quadrant 1. So I know I showed you this graph on Desmos, but I'm going to add it on here just to make sure. That was that graph. The graph above looked like this. And this graph looked like that. Make it look a little bit better. All right. So now the question is, what if we start comparing some other functions? So I'm going to look at 3 to the power of x and 4 to the power of x. And what I want to determine is which graph is increasing faster. So if it's increasing faster, that means the y values are getting larger quicker. So one thing you can do if you're using Desmos, if you can't tell by the graph itself, I can go and highlight each function. I can go to the settings bar, and I can convert it to a table. And if I don't see enough, I can add more numbers in here just by hitting enter. And I'm going to do the same thing with 4 to the power of x. And I'm going to add, some extra y values in here. So if you notice, as soon as x gets to be larger than 0, this blue function takes off running faster than the red. And if you look at x equals 3, it's very visible. For my 3 to the power of x function, I'll have 27. But for my 4 to the power of x function, I have 64. So in this case, if my ratio is larger than 1, the bigger number increases faster. Now, what if my ratios are fractions? What if it is less than 1? If it's less than 1, you'll notice this red function has y values that are smaller, quicker, over here on the left. And I'm going to go ahead and look at these tables. So here, I want to add in, -3, -2. Oh, actually, I have space. -4, -3, -2. Can I get rid of this one? No, I can't. Well, that's fine. I'm just going to add even more in here so we can see it even better. I'm going to do the same thing in here. Let's see, -5, -4, -3, -2. All right, so I've got 1/3 and 1/4. Now, because I want to know where they're decreasing faster, I'm going to look at this left-hand side over here, which means I'm looking at negative x values and comparing those y values. So at -5, the third is 243, but the fourth is 1,224. Or excuse me, 1,024. I can read numbers, I promise. And then if you look, -4 matches with 81 or 256. So now it's the smaller denominator that's getting me that decreasing faster value. Now, if you were to look at 1/3 and 1/4 as decimals, 1/3 would be 0.333 repeating, and 1/4 would be 0.25. 0.333 repeating is actually a larger value than 0.25. So that's another way that I can look at this 1/3 being the thing that will decrease faster. Its decimal ends up being a larger number than 0.25. So that 1/3 will decrease faster. So when you're working on your comparing functions activity, I'm going to come back to my document camera here. On my comparing functions activity, I have all of these different cards that I can look at, and you're more than welcome to use Desmos to help you figuring out what quadrant it would live in, if the ratio is greater than 1, if the graph is reflected, which is based on the coefficient. But ultimately, what you're going to do is take those letters and you're going to fill in where they would be on this activity sheet. I'm going to zoom out just a little bit more. So, for example, if I took the first one, a, 3 to the power of x, I would go through here and I would figure out if a fell in quadrant 1 and 2 or if it fell in quadrant 3 and 4. Is the ratio greater than 1? Is the ratio less than 1? Is it a reflection? What's the y-intercept? Well, I would write the y-intercept over here because I want to write the ones that have the same y-intercept. And then I would say if it was increasing or decreasing. So a lot of these letters are going to show up multiple times on your activity sheet. If you have any questions, please email me and let me know. Otherwise, this is your activity for today's lesson.